Hi, my name is Krish, and I'm here to talk about a specific graph that I derived. So this graph, it doesn't have any applications as a graph, but I think it contains some techniques which I think most high schoolers should know about. So, what is this graph? So basically, I once saw this one graph. It's absolute value of sine x divided by sine x, and it looks something like this. It's a flat line and a straight line and a flat line, straight line, and it goes forever on both sides of the x-axis. And I thought, why can't we have a graph where you have a flat line and then a slanted line and then a flat line and a slanted line going back down? So I derived a graph, a specific function in that graph to a specific function to get that particular graph. Now I could have easily used a condition in my grapher to allow for hybrid functions, but in that case I wouldn't have been able to manipulate the certain functions that my grapher already provides to me. And I felt by manipulating those functions, I was able to get a bigger feeling of achievement inside me. So that's why I decided to manipulate the functions. And the functions that I've manipulated are absolute value of x and a sine of x. Okay, so before I start explaining how I got to the actual graph, I want to explain a few other graphs. Okay, now we all know, I'm just assuming you know that the the graph of absolute value of x looks like this. It's a V shape. But to take it ahead, what if we added this to x? What would we get? Basically, this would move down by x and this would move up by x. So we would get something like this. Now you can't see this other part, but it's actually 0. I know this because by adding 1, this part becomes 1. Whereas if it was undefined, you wouldn't be able to see it even if you added 1. So coming back, now that if you see this part would be absolute value of x plus x. But all of this, for all of these values, absolute value of x is equal to x. So in this case, this is 2x. And what happens if I divide this function by 2? I'd basically get 0 in this place when x is negative, but I'd get 2x divided by 2, which is x when x is positive. So that's absolute value of x plus x divided by 2. Now what happens if I do absolute value of x minus x divided by 2? The same thing happens, except x is on the negative side. But this isn't exactly x. This is absolute value of x, because if it was x, it would be negative. So instead of putting absolute value of x minus x, I'll put x minus absolute value of x. And I'll get x when x is negative and 0 when x is positive. I know, again, I know that it's 0 because if you add 1, it becomes 1. And it's not undefined. So now we can proceed to the next part of the video. So how did I come to this graph? First of all, if you notice this graph, it looks a bit like sine x, but not exactly sine x. It's like sine x because it keeps recurring over and over again. But it's not like sine x because it's all straight lines. But what function is sine x, which is a straight line? It's it's basically a sine of sine x, which should give you something like this. Okay, when you have the function y is equal to absolute value of x plus x divided by 2, It's basically 0 before the y-axis and x after the y-axis. My bad. It's basically 0 when x is negative and x when x is positive. I say this because you can always change it to, let's say, x plus 1. No, wait. Let's say uh, x square plus x square. Now, this is not going to have any difference because x square is always positive. But you could have something like x square minus 1, and here also would be x square minus 1, and you'd have this value being 0. So it's basically whenever the function inside has is negative, it becomes 0, and whenever it's positive, it becomes uh, the function itself. So we can apply this to a sine of x and see what happens. Basically, when it's supposed to be 0, when it's supposed to be negative, it becomes 0, and when it's supposed to be positive, it becomes itself. And I have the graph of a sine x right here. So if you see this function, it looks a bit similar to what I've got here, but not quite the same. For example, like this is a bit lower, and we can't just merely shift it down one point. So what we do is, if you let's see the graph of a sine of x. It's basically this. And what happens if we shift it up? We get this. And what if we do the absolute value function on this? You'll get a graph like following the cursor, like somewhat like this, where it's 0 at these places. So let's try that. I'll just surround these by brackets. And add 1, add 1, and voila, we get this. But now it's not quite this, if you notice. Mostly because this is always positive or 0, and this can be negative. So here we can just shift it back down by 1, and we get this part. Now, we can do a similar thing with y is equal to absolute value of, no wait, y is equal to x minus absolute value of x, the whole thing divided by 2, which is basically x if x is negative and 0 if x is positive. So wait, let me just surround it by brackets. Now try making it a sine of x. Oops, I wrote a c. A sine of x, and we get a sine of x when it's negative. Now instead of adding 1, we have to subtract 1, because when we have a sine of x and we subtract 1, we can get we get this function, and then we can make these parts flat. So let's try adding 1 plus 1. Oops. Plus 1. Wait. Oh, I'm sorry. You're actually supposed to subtract 1. I made a mistake. So when you subtract 1, you get this function, and then you can add 1 again later, and you get this function. So I've got both of these functions, which get me, one of which gets me this flat line, and the other of which gets me this flat line. But I want both in my function. as you can see here. So what should I do? Well, this may be a bit weird, but if you see that this function is basically acting on another function, that is a sine of x. So and even this function acts on another function, that is also a sine of x. So what we can do is we can take this entire function, copy it, and choose this, and we can actually choose to remove make this flat for our new function. Well, our old the function that we found, this one here. So we substitute a sine of x for that function, and again here we substitute a sine of x for that function. So what do we get? We get this graph, and that is how you get the the movement of this, the general shape of. Okay, so once you've got both of these graphs, which one of which basically cuts off the graph at 1 and the other of which cuts off the graph at -1, how do you get this graph which cuts the graph at 1 and -1? Well, it's not that difficult actually. If you see either one of these graphs, let's say this one, this cuts it off at -1. Now, which graph is this function? I'm sorry. If you notice, this function is acting on another function. Like I've typed in another function over here. If I've typed in another function over here, and it cuts off the other function at -1. So what if instead of cutting off a sine of x at -1, I cut off this other function at -1? It so basically what we do right now is we take this function, we copy it, and we paste it inside the brackets of this other function. This other function, it's gonna cut the first function at -1, and the first function is nothing but the function that cuts a sine of x at +1. So as a result, both the functions cut a sine of x at -1 and at +1, and that is how you get this graph. Now you may have noticed in this that I have variables such as f and h. These are uh, these are not so important to the graph per se, but you can if you want to change the graph, they make it much easier. In this over here, f stands for function and h stands for height. So using h, I can alter the height of the function. Let's say I make it zero point 0.5. Now the graph is only zero point 0.5 long. But since a sine of x is, it peaks at pi by 2, I can't, if I make it anything greater than pi by 2, there won't be any flat lines. So for now I'll just keep it 1. Now f is a bit more interesting. If I change f to, let's say, x square rather than x, instead of a straight line like the x graph, you get a parabola like the x square graph, except that it's broken into pieces. Whenever it goes up, it goes. It's actually supposed to go up to pi by 2, but I've cut the height up to 0, up to 1. So it goes up to 1, then becomes flat for a while, then goes down to -1. And if you notice, it keeps, as the slope keeps increasing, the lines become closer and closer together. So that's how you use this, you alter this graph.